Morning, everybody. Welcome to math class, Wednesday, May 6th. I got a quick entrance test, final chance to do some review of algebra. They both have some simplifying here. On number one, you're going to have to use the distributive property first to simplify, then two algebra steps. For number two, you're going to do the distributive property, then combine like terms. Okay, they're both two simplifying steps. Then you'll have two algebra steps. So pause the video. Try these two and I'll go over the answers, and then we're going to move on to notes. Something new today, talking about square roots. Alright? Alright, hopefully you pause the video and try these two problems. See how you did. Here are the answers to both of them. Number one, we did the distributive property first here. 3 times the 4x is 12x. 3 times negative 5 is negative 15. Two algebra steps, adding 15 both sides, dividing 12 both sides, you get x is 4. 2, we distributed the 2 first, just brought the 7w down. 2 times 3w is 6w, 2 times negative 5 is negative 10. Combine the like terms, 7w and 6w is 13w. Then my two algebra steps, add 10 both sides, divide 13 both sides, and you're left with w equals 2. Okay, so those are very similar to the problems that you should have tried on page 3. That's due by Friday, the page 3 problems. So make sure that you try those, please. Let's look at the main part here. Some notes on page 4. So before we talk about the square roots, we're going to first talk a little bit about squares. Okay, just a reminder, I've gone over this a little bit. So it says, remember, we call 3 with this little 2 at the top there. We can call this 3 to the second power, or 3 to the second, or you'll hear it as 3 squared. Okay? And when you do this, this whole thing is called a power. The 3 is the base of the power, and the 2 is called the exponent of the power. So it's just a little bit of vocabulary. So the whole thing is a power, the 3 is the base, and the 2 is the exponent. Alright? And you hopefully remember that 3 squared is not 6. It doesn't mean 3 times 2, but instead, alright, we say that 3 squared is equal to 9. Why? Because 3 squared tells us that we multiply 3, the base, by itself 2 times. 3 times 3. And that gives us 9. So the exponent tells us how many times we multiply the base by itself. So here we have 2 3's there. 3 times 3. That's why there's an exponent of 2. Okay? Got some other examples we have listed here. We say 2 squared is 4 because 2 times 2 is 4. 4 squared is 16 because 4 times 4 multiplied by itself twice is 16. 5 squared is 25. 5 times 5, 25. 4 to the third power, also referred to cubed sometimes, right? That means multiply 4 by itself 3 times. 4 times 4 times 4 is 64. 4 times 4 is 16, and 16 times 4 is 64. 2 to the fourth is 16, because that's 2 times itself 4 times. Alright, so 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. There's our answer. So go ahead and pause the video and try those real quick. See if you can get those answers. Alright, so we would say, if you're back from unpausing it here, we'd say 6 squared, we would say is 36. Alright, and that's because 6 times 6 equals 36. You don't have to write that part down, but I'm just showing you why. 2 to the fifth would be 32. That's 2 times 2 times 2 times 2 times 2. So we keep multiplying 2 by itself 5 times, you'll get 32. And 3 to the third would be 27. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. Okay? So that's just a quick review on basics of exponents. Now, the new part here. Square roots. Okay? Square roots, it says, are the inverse operation of squaring a number. Okay? It's the opposite of raising a number to the second power. Okay? That's going to be important because we're going to be solving problems that have a square in it, like x squared. And if we're trying to get x alone, we have x squared equals any number over here. It doesn't matter what that number is. Okay? If I'm trying to do algebra to get x alone, I got to get rid of that exponent of 2. How do we get rid of an exponent of 2? Well, the opposite of squaring x is to take the square root of x. So I would, just like everything else we did algebra-wise, the algebra step would be taking the square root of both sides. And the square root of x squared is x. And over here, I'd put the answer to whatever the x squared of that number is, depending on what number is under that square root. All right, we're going to talk about calculating those square roots right now. But that's really important right there. So, this is pretty confusing when you see it just with letters in it, but this would be how you would see this written like in a textbook. We say that the square root of x equals y because y squared, when you multiply y by itself twice, you get x, the original number under the square root. So it says y times y equals x. Okay, so again, it's the exact opposite. And it says this is usually easier to see with numbers. So for example, we would say the square root of 9 is 3. Why? 3 is the number that when you square it, gives you 9, the number you started with. So you can see it's the exact opposite. 3 squared equals 9. So we'd say the square root of 9 is 3. Right? Because 3 squared equals 9. You're basically asking yourself, when you're taking the square root, what number when you square it gives me 9? That's kind of what you're, when you're taking the square root of 9, that's what you're asking yourself. What number, what mystery number, when I square it, gives me 9? Oh, that's 3. 3 squared is 9. Alright? So to make these easier, it's kind of like knowing your math facts. To make these easier to do by hand, here's another example. The square root of 16 is 4. Why? Because 4 is the number that when you square it gives you 16. So I was trying to say here, or I started to say, it's a good idea to remember the first, what we call 15 perfect squares. Okay? Perfect squares are numbers that you get when you square a whole number. Okay? These are the ones that you can take a square root of and get a nice answer. Okay? So here's the first 15 perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. How'd I get all these numbers? 1 squared, 2 squared, 3 squared, all the way up to 14 squared, 15 squared. Okay? Every one of those first 15 numbers, when you square it, gives us these perfect squares that you see above them. So 15 times 15 is 225, right? 11 times 11 is 121. 11 squared is 121. And again, those are just easier so that you can, as you keep doing these square root problems, you can do them without the use of a calculator. Now you can do them on a calculator too, or a calculator on your phone or your calculator. You're just going to look for this symbol to take the square root of a number and test it on one of these easy ones to make sure you're doing it right. So like if you type in the square root of 64 in your calculator, you should get 8. By the way, if you type in a square root of another number that's not one of these perfect squares, you're going to get a real nasty decimal. That's okay. You just have to round it usually because decimal is actually an irrational number, which means it's like pi. The decimal goes on forever without repeating. Alright, we're getting to the example part here, last part of the lesson. Okay, got some examples of square roots. So we say the square root of 25 is 5. Why do we say that? Because 5 is a number that when you square it, 5 squared is 25. What's the square root of w squared? Well, what number when you square it gives you w squared? W. Okay, why? Because the same reason here, 5 times 5 we say is 25. We would say w times w. Another way we could write that is w to the second power, w squared. And that's important for algebra, which we'll be doing next week. Square root of 100 is 10. Again, why? Because 10 is the number that when you square it, 10 times 10 multiplied by itself twice, you get 100, the number you started with. And we'd say the square root of y squared is y because y times y is indeed y squared. Okay, so most of them you have are going to be with numbers, but you will see some of them with variables. So go ahead and pause the video to try these ones. See if you can get them real quick. Okay, hopefully you're back. You paused it and tried. The square root of 49 is 7. 7 times 7 is 49. The square root of a squared would be a, because a times a is a squared. And the square root of 121 is 11, because 11 times 11 is 121. Alright? Now, an important thing to realize with square roots I haven't mentioned yet is that negative numbers work too. However, they call that the negative root. And if you just have a number and they want the negative root, like let's say for 49, they would put a negative out in front of the square root. It's very important it's out in front of the square root, not underneath, because if it's underneath, it's actually, there's no answer, there's no real answer, they call it, because there's no numbers in the real numbers where a negative can be under the square root. They actually, when you guys get to 11th grade math, they'll start to talk about a whole other type of numbers they invented to try to be able to calculate numbers when there's a negative square root. Alright? But for now, we'll just say if they want the negative of the square root of 49, it means they want the negative root. And that answer would be negative 7. Why? And that's the same reason, because negative 7 times negative 7 is indeed 49. The number underneath, right? Negative times a negative is a positive. So the negative answer works too, but we assume they want the positive root unless they put a negative out in front. Okay? By the way, if you're Googling stuff, these are called square roots. Another word that you'll hear sometimes for square root is the word radical. Okay? So sometimes you'll hear this called radical 49 or radical 121. It's just another word they use for square roots, in case you ever hear that when you Google something. Alright? And I'll use it some later on. So, these are your easier examples to start with. We'll be combining, like I said, algebra and these next week. But for right now, we're just going to spend today and a little bit of tomorrow just kind of practicing getting good at these square roots. So, the problems for you to try is page 5. Page 5, you have 8 of these basic questions to try. And then a couple of bonus questions that I'll go over. And by the way, I'll go over these answers on Monday after all of them are turned in. Okay, so again, go ahead and try these for tonight, and I will check in with you guys tomorrow. Have a great day. Bye.